Hi everybody, I'm back again with another video for you today. We're going to be doing more mathematical art in this video with my friend Sol LeWitt. He is a mathematical artist. He was a mathematical artist. He passed away. Sol LeWitt isn't really my friend. I've never met him before, but I kind of feel like I know him because I appreciate his art so much. And that's something special about art and books, is that you can see some art that you enjoy, you can read a book that you enjoy, and it kind of makes you feel like you know the artist or you know the author of the book because you enjoy their work so much. You feel like you have gotten a little bit close to them. So today we're going to get a little bit close to Sol LeWitt and look at some of his artwork, and then you're going to create some of your own mathematical art as well. So let's go ahead and take a look at the board here. All right, up on the top here I've got mathematical art. Now you've seen those words before a couple videos ago, and this is using math to create art. That's all it is. And in mathematical art, we usually use a special type of math called geometry. The G says j, j, and then it's a long E, j, E, geometry, and the Y says E, geometry. Now, geometry is math using lines, shapes, and space. We talked about space a couple videos ago. A space is an area of any shape that you can put things in or fill up. So geometry is the math that's using lines, shapes, and space. Now, I took some of the information from our art board in class, and I made a list here of some of the most common lines that we use when we do our artwork. And I also made a list of some of the most common shapes that we use when we do our artwork. Common means things that we see a lot of, that we use a lot of the time. So I have some lines and shapes here, and we're going to be using lines and shapes today to create some art which is similar to that which was created by Sol LeWitt. Sol LeWitt. Now, Sol LeWitt was an American artist. He was born in 1928. That was almost 100 years ago. And he died in the year 2007, a few years before all of you were born. Here's a picture of Sol. This picture was taken back in the 1960s when I was a little boy. And this is what he looked like back then. So let's go right ahead and take a look at the next board. And I'm going to show you some of the different ways you can create mathematical art in the way that Sol LeWitt did. So I'm going to show you some samples or some examples of some of his artwork. Now, when you're given a space and you can to create some mathematical art, there are different ways you can do that. First of all, you can use your space to create a symmetrical design. Remember, a symmetrical design is the same on the left and the right, but they're mirror images, which means they are reversals of each other. So the line of symmetry goes right down the middle, and whatever's on this side of the line of symmetry matches whatever's on the other side, the right side of the line of symmetry, but they are mirror images. They are backwards from each other. That's the first type of mathematical art that you can do. The second type of mathematical art that you can do is where you take one or two kinds of shapes and you use them over and over again, but you make them look a little bit different. So in this picture right here, this painting, which is called Complex Forms, Sol LeWitt used a lot of triangles, and he used a few four-sided shapes as well, but he made them different from one another. So all the triangles have three sides and three angles, but they're not quite the same shape of triangle as the one that might be next to it or on the other side of the painting. Here's another one where Sol LeWitt used the same shape, but he made it different lengths. Some of the rectangles are long and skinny, like this yellow one. Some of the rectangles are kind of short, like this blue one. And there's even a couple of squares in that picture too. I'm sorry, in this painting too. Now, this painting is very interesting because when you look at it, it looks like it's a whole bunch of squares with one inside the next one that comes around. But it's actually not. Those would be called concentric squares. Concentric, that's a big word, and that just means that each square is inside of a bigger square all the way out to the edge. But these are not concentric squares. If you look very closely down here at the edge, you can see that this line ends right there. It's underneath this line that appears to be the bottom line. And if you follow that line over to here, follow it up to here, now look at the corners. You can see that the lines bend a little bit. So they're going inward, getting a tiny bit smaller, and they go in like this, creating a square spiral that ends right there. Follow it back around, and you can see that these are not concentric squares, it is a square spiral. That's part of the magic of Sol LeWitt, is that he can create something that looks like something when we first look at it, but when we take a closer look, we realize, hey, that's just a little bit different than what I thought it was. And that's what's great about his artwork. It's kind of like solving a mystery sometimes. Let's take a look at a few more. All right, so you can make a symmetrical design. This one, by the way, is called wall drawing number 370. You can create some mathematical art by using one or two shapes over and over again, but making each one slightly different than the other one. Now, another thing that you can do is you can take some small shapes and turn them into a bigger shape. Look at what Sol LeWitt did here in color bands in 4 directions. A band is kind of like a line. So he took these long rectangles and he put them together next to each other and created a bigger rectangle. These are vertical. Now he took some horizontal long skinny rectangles and created another big rectangle. Here he did the same thing at the bottom. It's small shapes that were put together in a way to make a larger shape. And when he took all 4 of those striped rectangles and put them together, he made something that looks kind of like an abstract window. So small shapes into big shapes. Now this one I like a lot. And I'm going to kind of zero in on that one a bit. In this one, he took some plane shapes. Remember, plane means flat. And he put them together in a way to make them look like solid shapes. They look like rectangular prisms. This one looks like a cube. But he took these plane shapes, 3 in each section, and arranged them in a way to make them look like a solid shape. He took small shapes and made them look like a bigger shape. So that's 1, 2, 3 different ways that you can do your mathematical art. Now another thing that you can do is you can just use many different lines and shapes. Waves, vertical lines that look almost like triangles. Here are more waves, but they don't look the same as the top waves. Here are some straight horizontal lines. And look at this one with all the curves in it. To me, that looks a little bit like wind or maybe even sailboats out on the water. But in this painting, which is untitled, Sol LeWitt did not give this painting a name, so it's just untitled. He used different kinds of lines and shapes, put them together, and he created his work of mathematical art. Now, the last type of, or the last way that you can do your mathematical art is to use just 1 or 2 kinds of lines. So here you have curved lines. But it's basically the same kind of line over and over again. Now this next one is one of my favorites. It's not very colorful, just black and white. But he created something here with vertical, horizontal, and diagonal lines called an optical illusion. Optical means something we can see, and an illusion means it's not really what we think it is. So if you look at this, it's flat, but it looks like a cube. And right here, that either looks like a cube going in or a cube coming out. And if you look at it in a different way, it might look like a corner with a little box in it. That's an optical illusion, and some artists do a really good job creating optical illusions. This one is kind of an optical illusion up here as well, because when you first look at it, it looks like concentric squares, squares inside bigger squares. But when you take a good close look and you notice this little end point right here, and you notice that at the corners, the lines bend inward, you realize that it's not concentric squares, it is a square spiral. That's an optical illusion as well. You know what? This symmetrical design is an optical illusion too. Do you all see a triangle in the middle? I can see a triangle right here. But you know what? There's no line here or here for that triangle. So it's not really a triangle. But the way Sol LeWitt painted that painting, it makes us believe it's a triangle because of the way the horizontal and vertical lines meet with each other. It looks like there's a line here and here when there really isn't. There is a line here, but not here or here. So I like optical illusions because they tend to make your mind wonder, and they tend to make your mind see things in different ways. You can look at this one and probably see it in at least 4 different ways if you imagine that this is not a plane shape, but it's actually a solid shape, something like a cube. I want this to be your artwork. When I look at it, I want to be able to see your name coming out of that artwork. When I look at it, I want to be able to see you. I want to be able to know this is your work. So use Sol to be your inspiration. An inspiration is something that gives you an idea. But then create your own artwork. Now let me show you what I've got. And parents, this is on the website in the video support section for video 12. So what you're going to find there is you're going to find 3 spaces for you to use to create mathematical art. Now you can use all 3 of them, or you can just use one of them. Here is space number 1, a rectangle. And your job is going to be to fill that rectangle, no empty space, with lines or shapes in any of the different patterns that I talked about a few minutes ago. Space number 1 is a rectangle. Space number 2 is a square. And I really think you'll like this one. Space number 3. Now remember, this is a plane shape. It's perfectly flat, right? But when you look at it, it's an optical illusion because now it looks like a cube. And you can use this space, 1, 2, 3 parts to that space, to create your mathematical art. Now, when you're doing your artwork today, I don't want you to think about numbers. I want you just to think about filling your space, and I want you to have a plan when you decide to do your artwork. I want you to think about whether you want to create a symmetrical design, a design with 1 or 2 kinds of shapes, a design where you take small shapes to create a big shape, maybe just use 1 or 2 different types of lines, Or maybe use a lot of different lines and shapes. I want you to have a plan of how you're going to go about creating your mathematical art. And maybe you can even challenge yourself to create some sort of an optical illusion, something that doesn't look exactly like what it is. Okay, so that's our video for tonight. That's your activity to do. Create some mathematical art. There are 3 spaces that are on the class website in video support, video lesson 12. You can use all of them or just one of them, but I can't wait to see the pictures of what you come up with. Oh, and by the way, remember Sol LeWitt, a couple of his paintings were not colorful. They were just black and white. The rest were all very, very colorful. You can do yours any way you want. Use pencil, use a black crayon and a white crayon, use many different crayons, paint it, use oil pastels, markers, colored pencils, or just a regular pencil, whatever you would like. As long as it is mathematical art, as long as you fill the space completely with lines or shapes, and as long as you're doing your artwork, you have a plan of exactly how it's going to end up looking at the end. Alrighty? Have a good time. If there's anything you need, just let me know. Take care, and I'll see you again soon. Bye-bye.